Okay, this is your pre-test quiz. Let me get a different one here. There we go. For Unit 9. Okay, so the first two questions here are talking just about molar ratio. So we're asking for a ratio, so it should be one number to something else. And so up here, these molar ratios are going to come from the coefficients up here. So when I balance this correctly, that's going to be a 1, that's a 2, and that's a 2. Okay, some people got something like a 4, 8, 4, 8. Well, those all can be reduced to that 1 to 2 to 1 to 2. So we can't use those because we should be reducing. So I look at copper to silver. Well, copper is 1. Silver nitrate is here, so that's a 2. Copper to silver, copper is 1 again, silver is 2. So both of those were actually 1 to 2. And I'm asking for a ratio, and that's a ratio form. Okay, the next one, use this equation for 3 and 4. So, so I need to finish in how many liters of oxygen? Well, that's going to be liters of oxygen. That's going to be my my label. At STP, that's needed because we're talking about a gas. Reacts with 2.00 moles of aluminum. Okay, that's my given. So up here's my equation. I need a balanced equation because I'm going from aluminum and into oxygen, two different substances. I know I'm going to need a Stoich step in there somewhere. So I first need to get out of moles of aluminum and into moles of what I'm trying to get into, and that's oxygen. Well, here is your Stoich step because I'm changing compounds, right? This Stoich step really piggyback off of this right here. This is the molar ratio. So what number comes in front of aluminum? That's a 4. What number comes in front of oxygen? That's a 3. So that's what I should see there. Now, I'm out of moles of aluminum, I'm in moles of oxygen, but I need liters of oxygen, which means I need to get out of moles of O2 and into liters of O2. Well, that conversion is 1 mole is equal to 22.4 liters of any gas, not just oxygen. That could be hydrogen, could be chlorine, or any other gas, right? At STP, which is why that's there. Okay, so now I'm out of moles of O2. I'm in liters of O2. That's a good thing because that's what I need to be in. So I saw a lot of calculator issues, and so to fix those calculator issues, we need to make sure we're using parentheses on the bottom. Now in this case, we don't really have a bottom. That's anything but 4. But so it should be 2 times 3 times 22.4. That's my top. And then when I push the division sign, that's my answer from the top. And then I need to use parentheses of 4 times 1. Now, I understand that this can be a 4, but that number is not always going to be a 1. And that's how I need to input into my calculator. When I do that, I get 33.6. Now, when I go back up to my given, 3 sig figs, that is my answer. Okay? Number 4, how many moles of aluminum? So again, moles of aluminum is going to be my unit for my answer from 24 grams of oxygen gas. Well, 24 grams of O2, I need to turn into moles of aluminum. Well, the big thing here is I don't start with moles. So right here I started with moles, and so I go straight to my Stoich step. Because I'm starting in grams, I need to first turn grams of O2 and into moles of O2. Okay? So to get out of moles of O2, this is your molar mass, which 16 times 2 is 32. All right? A lot of people want to put 16 there, but the molar mass of O2 is 16 times 2. Will give me 1 mole of O2. Then I'm out of grams of O2. Now I can get out of moles of O2 and into moles of aluminum by my Stoich step. Those Stoich numbers come from my coefficients from my balanced equation. So moles of O2 to aluminum, well, 3 to 2. And so now I'm currently in moles of aluminum. Well, that's what I want to be in. So I'm done converting. Now I need to make sure I do this with my calculator, all right? 24 times 2 equal, well, that's my answer to the top. And then I need to put everything in parentheses on the bottom, 32 times 3. And that should be 0.5. Well, I have 2 sig figs, so 0.50. There is your answer. Okay. The next one. So use the following for number 5 and number 6. Phosphorus, which is not diatomic, reacts with chlorine gas, which is diatomic, to produce phosphorus trichloride. This is covalent. There we go. Right? And so to balance this, that needs to be a 3, that's a 2, and that becomes a 2. All right, so this is essential to answer this question down here. Once again, how many moles of chlorine gas? So I need moles of chlorine gas as my unit for my answer, come from 17 moles of PCl3. Well, 17 moles of PCl3, and I need to get out of moles of that. Right? And I can get into moles of chlorine gas. So this is just a one-step problem. This is your Stoich step right here. And so I have 2 to 3. And again, when I take 17 times 3 divided by 2, I get 25.5. Okay? But 2 sig figs, so it should be 26. There you go. On the back is where it gets a little more difficult, okay? And so just like in the mini quiz number 3, we need to look at all of this. So you're using this example right here for 7, 8, and 9, okay? So this is how these should be attacked, right? I'm given iron, and one experiment, iron reacts with sulfur. Well, iron reacts with sulfur. Neither of those are diatomic, so I'm not going to put a 2 there. Calculate the mass of iron 3 sulfide that can be formed. Well, this means it's forming iron 3 sulfide, right? Because this is iron 3, that 3 gets crossed down, sulfur gets crossed down here. There should not be a 3 right here with this iron because it's just by itself. It doesn't it's not reacting with anything yet. So that's your skeleton equation. Now I need to balance this. So this should be a 2, that should be a 3, right? And we're balanced. So notice how I'm given both of my reactants. I need to find a max mass of iron 2 sulfide. So how much of this can possibly be made if I have that amount and that amount reacting together? Well, this is a limiting reactant type of question. So I need to turn 7.62 grams of iron and 8.67 grams of sulfur into that product. That will give me 2 different numbers. All right, so let's do that. So to get out of grams of iron, I need the molar mass, which is 55.85 grams of iron. That will give me 1 mole of iron. So I'm out of grams of iron, I'm into moles of iron. I need to do that so I can get to my Stoich step, because the moles of iron will equal the moles of Fe2S3 by the molar ratio, which is 3 to 1. Right? Here's your Stoich step. I'm out of moles of iron, I'm into moles of iron 3 sulfide, which is better. Now I need to get out of moles of Fe2S3 and into grams of Fe2S3. How do I do that? Well, the molar mass of that thing, which is 207.88. Okay, so I'm out of moles and I'm in grams. This should give me an answer of 14.181. Okay, so that's just the most possible that can come from that amount of iron. Well, let's see how much we can get from this one. Okay, so I do the same exact process. Now I'm just using sulfur. The molar mass of sulfur, 32.06 grams of sulfur is 1 mole of sulfur. I do that so I can get to my Stoich step to go from moles to moles of something else. So moles of sulfur, we can get into moles of Fe2S3, and this one is going to be a 2-to-1 ratio. Okay, so I go here, and then I know I'm out of moles, and I know that 1 mole of Fe2S3 has a mass of 207.88 grams of Fe2S3. Well, when I do that math, I get 18.739. Okay, so it's significant because we see that this is the lower amount of mass that can be made. And the thing is, this much will not be made at all, because once this is used up, that stops. So there's going to be excess of this, which means the max amount, and this is one of the biggest mistakes I saw on this quiz. A lot of people got these answers, and then they wanted to put 18 there. Well, 18 cannot be produced because this will get used up before this. So the max amount comes from your limiting reactant amount, which is 14.18 grams. Okay. Now your limiting reactant is going to be one of those two reactants, and this 14.18 comes from iron, so iron is your limiting reactant. Okay. Now down here at the bottom, this really uses this work to make this a much quicker problem. From the reaction above, if a student is able to produce 13.01 grams, well, actual over theoretical times 100 is my formula for 4% yield, right? So actual is from a lab, so that 13.01 goes on top. Well, what goes on bottom? This is a theoretical, which means here's my theoretical yield. That means that number gets put there, 14.78. Multiply that, or divide that, then multiply by 100. I should get an answer of 91.75%. Okay. So once again, your limiting reactant becomes the max amount that you can possibly make. Then that is your theoretical yield that gets put into your percent yield problem. Okay, multiply 100, rounded 2 decimal spots. I hope that helps.